starting our unit on statistics and probability, which comes up lots of times. So probability is the chance that something is going to happen. You're like, you've probably heard, like, what are the chances of that? Or you look at the weather and they're like 30% chance of rain. So it kind of combines some of the percentage stuff that we've done already and chances of things happening right now. So here, like 10% chance of rain. What does 10% mean? Like we can talk about, remember we changed percentages to decimals. To fractions. 10% is a 0.1 chance as a decimal. As a fraction, it's 1 over 10, which we can say as a chance 1 out of 10. I've got a number in my head between 1 and 10. I'm gonna get it, I'm gonna get it, I'm gonna get it, I'm gonna get it. Okay, I got a number. You've got a 1 in 10 chance of guessing it right. What do you think? 5, no.
8.
8, look at that, he got it. Second try. Right? And then you can watch the videos.
That's your aura or second chance. Yeah.
So you'll notice in the notes there's a few boxes that you got to fill in, right? You got to fill in the probability, the likelihood. Sometimes they use percentages, and sometimes we talk about things like likely and even chance. Like if it's unlikely to rain tomorrow, it's probably like a 5% or a 10% chance. If you see this word, even chance, that's 50% as a fraction. That's 1 out of 2. If you flip a coin, your chances of getting heads is 50% because there's 2 sides to the coin and one of those sides is heads.
Could be 33, sir. 33.3%.
Yeah.
It could land
I
on.
don't know about that.
You can my
No. No. Or me. Yeah, I can't remember. I don't know what I handed you.
So we've got probability ranges from impossible to certain. There are some things that are impossible. Right? Here we go. Here we go. Here we go. Here's an impossibility.
I'm possible.
I'm going to roll this die until I get a 7. 2. Three.
Guys, it's
How
gonna
long
be,
will I have to do this before I get a 7 on this 6-sided die? It's going to be impossible. There are some things that are impossible.
That's fair.
Okay?
That's
There
fair.
are some things that are certain. Okay? Okay, we're going to play a game. If I roll a 1, 2, 3, 4, 5, or 6, you win. Excitement. Just, here we go.
Winner!
You're a winner.
So it's certain.
It's certain, right? If we said all 6 of those numbers, it's going to happen every single time. That's certain. Can you give me something to roll on here that would be an even chance? 50-50.
3.
3?
Like
Oh.
it's impossible.
4.
Well, you can come up with a situation so you win half the time.
Like 3 or below or above.
3 or below. 1, 2, or 3, you win. 4, 5, or 6, you lose. Or even numbers, 2, 4, and 6, you win. Odd numbers, 1, 3, and 5, you lose. That would be an even chance because half of them win, half of them lose. So we've got this as probability, and they use a lot of probability in games. They use a lot of probability in games which they try to encourage you to play, but in the end, the probability is against you. because gambling companies want to make money, so they make sure the probabilities work in their favor. And we can figure out probabilities. Oh, I invented a very addicting game. And I figured out the probabilities. And if we played this game 100 times, I would win $83. Okay? But when you play the game, you actually win. It's like 85% of the time. You win a ton of the time, right? So the way the game, this is the game that I invented. It's expensive to play though, but you almost win every single time. You pay $50 to play. Then I roll the dice. And whatever the number is on the dice, you get your $50 back plus that amount of money, unless it's a 7. It's a 7, you lose your $50. So Mr. Shirk goes to play, puts his $50 down, I roll the 4, I give him $54. Right?
Yeah.
So this is how it works in the game. He was a winner. Ruben's a winner. Logan's a winner. You won $11, you big man. Stacy is a winner. Law is a winner. Holly, winner. You won $10. Right? And if you watch this and you just saw winner, 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 be like, I want to play. Abel, winner, $2. $8 for you. Right? $4 for you. So I'm just dishing
So
out
everybody's putting in
Right.
50 now.
Bill Brody,
Cool.
you just lost $50, man. But your chances of winning are high, but when you lose big. But it could be very addicting because you're like, chances of winning are good.
Win, win, win.
And then when you lose, you're like, I want to win some of my money back. So you play again, hey, you won $4 back. Want to keep going? You just won another $9 back. Want to keep going? You just won another $5 back. You want to keep going? You just won $9 back. So you're like, yeah, I want to win. You won $11 back, you're almost even. Right?
Here's the
Another
thing.
$5.
Here's the thing though, you started with putting 50 that you could lose.
Mhm.
And it's your 50. So you'd have to win X amount of times to get to 50
You get
so
back.
that to get back what you've already put in. And then when you get to that point, you could get a 7
And you're down again.
and you're right where you started.
Pues llegar, es como en el casino que cuando tú ganas, la carita feliz te da en la manzana y te hace jugar otra vez y gastar $15 más.
Okay. So, probabilities can be represented as fractions, as decimals, or as percentages. Okay? The nice thing about the fraction is we obviously have a certain amount of possibilities. Like on a die, there's 6 sides, 1 to 6. So it's really easy to figure out what's the probability I roll a 1. Well, there's only one 1 out of 6 chances. That makes our fraction 1 out of 6. Changing it to a decimal, you need your calculator. Changing it to a percentage, then probably need your calculator as well. Getting one of the numbers on a die is a 16.67% chance of happening. Okay? Some other definitions. We've got some spaces here, so fill them in. The first box, experiment, is a process or observations that can result in different possible outcomes. So if I roll the die 5 times, that would be an experiment to see how many times things could happen. Have you ever heard of weighted dice?
For one side weighted, so
They make it weighted so when you roll it, it tends to land on that more often. So you get what you want.
You don't wanna see that in Vegas.
People, yeah, you get in big trouble cheating. Sample space is the set of all possible results or outcomes. So if I would roll a dice, my sample space would be 1, 2, 3, 4, 5, and 6. Because those are the possibilities. And each of those possibilities are called an event. Right? So an event is part of the sample space. And this is, I'll put a box around this. This is our theoretical probability formula. So in theory, if I roll a die 6 times, I should get a 1 once. I should get a 2 once. I should get a 3 once, a 4 once, a 5 once, a 6 once. Does that happen? It doesn't have to, right? Is it possible to roll 2 2s in a row? Absolutely. In fact, I'm going to pull something up here just to show you while you're writing these things down. Too bad Brandon's not here. He has this calculator. He can play with this.
He's missed a lot lately.
Which one we're looking at?
Well, for starters, 0s and 100 for
500 more. This one. Nathan
This
said he
one.
wasn't here. Nathan, you were here? See, well, maybe
for the
not.
quiz.
On Thursday?
Yeah, he was.
Yeah. But
Yeah.
0 instead of X. So
Right. So I would go half a mark on this one because he's got the
And
sign right.
there.
Nothing on this one.
no, exactly.
Yeah.
And
And then
then I can't give anything here. I
Yeah.
don't think.
-3 to 6. It's got the idea, right?
Yeah, except for
That
colored
one's-
in.
and
No
this one,
dot.
no dot.
Here it's
So,
backwards.
You could give this one. This one should be an arrow. And this one should be. This one you could give a half. Yeah. That one wrong. And that one wrong. Yeah.
Okay. And then same thing here. X equals 4.
Yeah.
0.5.
Yeah. So there's no equal sign there. Yeah.
Literally the cleanest I've ever been.
Okay.
Yeah, that's what we have.
On this calculator, I can do all sorts of things. I'm gonna roll some dice right now. Number 2. And pick OK. Oops. OK is this button. There. Look, I've got the numbers 1 through 6. If I roll once, I got a 6. Now, if I roll another time, I got another 6. What are the chances of that? Okay. But if I roll 10 more times, so right now we've rolled 12 times. According to this, someone would say, I think the 6 is the most likely to happen. Shouldn't they all be the same though? What theoretical probability says, they should all be 1 out of 6. What experimental probability shows is that sometimes it's a little bit different. But if I did it another 50 times, oops, I got the dot. Put my pens down. If I did it another 50 times, and then another 50 times, and then another 50 times, and then another 50 times, as I do it over and over and over again, what do you notice? Are they about the same?
Getting close.
Getting closer and closer to being about the same. And what's nice about this program is I just rolled one die 1,562 times. And they're all about the same. I'm gonna clear this out. I'm going to roll 2 now. When you roll 2 dice, does it make sense that 2 is the lowest?
Yes.
And 12 is the highest?
Yes.
But with 1 dice, 1 to 6 is all the same. With 2 dice, are they all the same? Or are some more likely? Any guesses? Have you ever played a game where you roll dice? 2 of them. Do you get 2 1s very often? Do things add up to like numbers like 5, 6, 7, 8 more often? Okay, so now what's gonna happen here? I'm gonna roll once. I'm gonna roll once. I'm gonna roll 50 more times. 50 more times, 50 more times. Which one's happening the most?
8 or 7.
The 7 is the most, then the 6 and the 8. Look at how it's making almost a perfect pyramid now. It's like, look at the 2 and the 12 are the lowest. So this is an experiment, but I got a computer to do the experiment for me randomly 2,051 times. Because it would be kind of annoying to, I got a 9, mark it down, mark it down, mark it down. So we can figure out the probabilities of these. It sure looks like the 7 happens more often. That's why in a lot of games the 7 is so important, because it's the most likely thing to happen when you roll a dice. And the reason for that is, how could I get a 7? In fact, it's even easier if I do it this way. All right. I've got a little die and a big die. See them? See they're different sizes? How could I get a 7?
4 to 3.
A 4 and a 3. 1 and a 6.
Bigger die.
5 and a 2.
5 and a 2. So 1 and 6, 3 and 4, 2 and 5. But I also could get 1 and 6 with the little one getting the 1 and the big one the 6, or I could get 1 and 6 with the big one a 1 and the little one a 6. Those would be different chances. There ends up being 6 different ways to roll a 7. There's only one way to roll a 2. You have to get the 1 and the 1. Oh. True story. As a kid, I was playing Monopoly, and I wanted to get a 2. And do you know the nickname for getting a 2 on 2 dice? You know the nickname? Snake Eyes. Snake Eyes. So what I did during the Monopoly game is I put the die into my eyes like this. And I let them fall out, and as they were falling out, I said, "Snake Eyes." 3 times in a row, I got it.
That's crazy.
That's crazy.
That's those moments you can't
Yeah, you just like
re-
as kids we were screaming.
yeah, of
It's
course.
so much. It's like,
You
what
can't
the,
re-
what did you do?
You can't
And I
recreate
held
that.
So a theoretical probability is important, because if you do experimental probability enough, theoretical probability will appear. However, so this is where poker players and people that play games, they're thinking about the theoretical probability, and they're saying, I should win in this situation. But there's always a chance that they don't. However, there are sometimes you're playing a game and you can look at the probability and go, it's certain. I have the best hand 100%. I know that I'm going to win. And then the strategies involved with the games like that. So, what is the probability of rolling a number greater than 4 on a standard die? And again, the theoretical probability, the bottom number is always the total number of possible outcomes. So the total number 1, 2, 3, 4, 5, 6. There's 6 possibilities. How many are greater than 4? Well, this greater than, that was our last unit, right? That's that sign. Greater than 4. 4 is equal to 4. 4 is not greater than 4. Only the 5 and 6 are greater than 4. So then your chances are 2 out of 6, which you could reduce to 1 out of 3. That's a 33% chance. So I want you to look at the spinner. The spinner has the number 1, 2, 2 number 3s, and the number 7. So your sample space is 1, 2, 3, and 7. Those are your possibilities. I want you to tell me what the probability of each of those things are. I'll show you the answers in a second. So in probability, you'll notice in the next question, so when you're trying on your own, you'll notice in that next question that we use a P to say probability of, and then we write a number inside. So look at that spinner. 4 possibilities. Each one of those pieces is equally cut out. So they're equally likely. Even if you're uncertain, I want you to put down what you think. If you had that question on a quiz or on a test, and you had to write an answer, put down what you would think, because it's when we take those chances and try things, we're gonna find out what we know and what we don't know. So I want you to write answers for each of those in question 2. See how you do. Well, I'm gonna put up the answers in a bit. You ready? Have a look, see how you did. The sample space, 1, 2, 3, and 7. If you wrote your sample space and added an extra 3 in there, I wouldn't be mad. You don't need to, because the 3 is the same thing. But the nice thing about adding that extra 3 is you can see that there are 5 possible places you can land. Of the 5 possible places that you can land, how many of them are 3s? 2 out of 5. How many of them are not 3s? That's the yellow, the blue, and the green. That's 3 out of 5. A 1 or a 7?
Yeah.
The number is at least a 3. That would include the 3, and the 7. That would be 3 out of 5. Okay. So are we getting the idea of the probability? This is the total number of possibilities. Do you see that there's 5 different things that could happen? They're all equally likely because they're all the same size. On the top is your chances of the thing happening. So to get a 3, you see that 2 out of the 5 sections are 3s. So then our probability of getting a 3 is 40%. No, I wasn't going to show you. I'm going to let you. A letter is randomly chosen from the word probability. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 6 questions to try to solve on your own. I'll put them up in a second. Include the Y, or do we not include the Y? I included the Y here, but I would also, if you would have done it vowels and not included the Y, I would have accepted it. I guess in this word, I think in this word, the Y is acting like a vowel. And then in consonants, again, this one, if you included the Y there, I would accept 7 out of 11. A vowel or B. Well, there was 5 vowels and then 2 B's. That makes 7 in total. So that makes that 7 out of
Is there
11.
like a review thing for the quiz? 'Cause I think I only got one for the test.
There wasn't. We really, let me think.
Shut up. Bro, you help.
Like I had this worksheet that we kind of used as practice. Did you get this?
No, I don't think so.
Okay.
I'll get that. And then can I do the quiz like on a Wednesday or something?
I should feel that.
Thank you, you should do that for me. I don't
I feel bad about that, man.
Okay, we're gonna do the next one together. Decide whether the probability of each of the following happening is less than half, equal to half, or greater than half. And I'm gonna put this so we don't see all the answers right away.
Oh, from Woods?
Yes, yes, depending on which math class you take. Pre-calculus and applied, yes, we'll have an exam.
What about essentials?
Essentials class is one grade.
See the wood shop, bro.
Yeah.
So goodbye lunch plans and goodbye have my phone today.
Okay. Coming up heads is exactly 50% of the time. Ooh, this has got some math wording in it on this one. Do you know what a prime number is?
Like a number that can be multiplied by 1 or itself.
Right, divided by 1 in itself to get a whole number. So the number 4, you can divide it by 2 and get 2. So number 4 is not a prime number. But the numbers 2, 3, and 5, you can only divide by 2 or 1. Those are the only things that in your times table that multiply it to get it. Now 1 is not considered a prime number. So the only prime numbers are 2, 3, and 5. So that makes 3 out of 6, which is equal to a half.
Yeah. ¿Y cómo se resuelve ese?
This one?
No, así.
Yes. How do we find this? Well, there are 6 possibilities. These are the ones that are right, which is 3 out of 6, which is the same as 1 out of 2, which is 50%, which is equal to a half.
¿Por qué el 3 y el 6 se dividen?
Because there are 3 ones that are prime numbers, and on a die, there are 6 possibilities. ¿No ve? 1, 2, 3, 4, 5, 6. 6 posibilidades. Y solo 3 son prime numbers. The temperature on Christmas Day will be a high of 5 degrees Celsius. Do you think that is equal to 50% of the time on Christmas in Winnipeg has it been 5 degrees? Do you think the chances of that are 0? Could it possibly be? As possible, right? Unlikely. So this is definitely going to be less than 50% of the time. Probably less than 10%, probably less than 5%. Very rare. I once spent Christmas at my uncle and aunt's in Calgary, and on that day it was 20 degrees. It was so weird.
Oh, so you can just like walk out.
So,
That's the Chinooks.
yeah. Okay, what do you think on this one?
Finish my.
You select a card from a standard, that S shouldn't be there. Can scribble it out. There we go. From a standard deck of cards. And it is not a face card. Do you think you have a better chance of getting a face card or not a face card? Or is it exactly 50%?
More.
Better chance of getting a face card or not?
Yeah.
Did you get a face card? Nope, he got a 5. Does it make sense that this one would be more than 50% for not a face card? You could actually count it. How many cards are in the deck? 52. So if I wanted to get, let's do face card first. Probability of a face card is going to be something out of 52. How many face cards are there? Jack, Queen, King. Ace is not a face card. Doesn't have a face. That's why they call them face cards.
Where'd the Joker go?
I guess, but we're only doing 52. We're assuming the jokers are out. So how many face cards are in one deck?
King.
King is one of them. How many?
Queen.
12.
Yeah.
12 out of 52 is the chance of getting a face card. Now we did this earlier on the calculator. Remember when I threw two dice on the calculator and I had a whole bunch of possibilities and we saw that, I think my calculator's still here, I can even open it up for you. Right? We rolled it 2,051 times and we found out the 7 happens the most. Now we're going to do the theoretical probability of this. If you have a chart like this, check out the numbers. There is only one way to get a 2. Is if you roll a 1 and a 1.
Bless you.
Thank you. Can you see there's 1, 2, 3, 4, 5, 6 ways of getting a 7?
Oh. Okay.
So the chances of rolling a 7 are 6 out of, do you know how many numbers I filled in total in here?
How many?
Can you figure it out? It's not that hard. How many numbers?
12.
No, there's, no, like, how many different numbers? 1, 2, 3,
36.
4, 5, 6? No, 36. Yes.
En 144.
6 times 6,
144.
36.
35.
6 por 6. Hay 36 números. And there are 7 happen 6 times. So if I do that, 6 out of 36 reduces to 1 out of 6, which is a 16.7% chance.
Oh.
It is not very likely that you roll a 7. It only happens 1 in 6 times. However, it is the most likely. The 7 happens the most. A 2 only happens 1 out of 36 times. So when we look at filling in that chart, I'll let you fill in that chart. Then we're going to find these probabilities together. You see the pattern when you're filling it in? It's sort of like 1, 2, 3, 4, 5, 6, 7. Then 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8, 9.
Yeah. ¿Y qué significa chip-chap?
Nobody knows. So we already did part 2. We already did the sum of 7 is 1 out of 6. But I want you to figure out the other ones. So there is a lot of counting in probability. We had to count that there are 36 total possibilities. How many of them are 3s? Look at your chart. 2 of them. So when we write this, I'll give you the answers for the first 3. There's 2 out of 36. That reduces to 1 out of 18. The 7, there was 6 of them out of the 36, which reduces to 1 out of 6. How many are less than 6? I'm gonna take out my highlighter for that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Does it make sense that I got 10 out of 36 as my probability? So now we've done those 3. See if you can figure out the next 3 on your own. I'm gonna erase my highlighters. There we go. How did you do for these ones? More than 8. Did you count that there was 10 of them more than 8? For more than 8, would you include the 8s? No. Less than 3. Oh, there's a mistake in this one. A sum less than 3, there's only one less than 3, that's the 2. And if you counted how many were even, count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of them. 18 out of the 36. That is exactly half.
Anything but grading the test.
Right.